Hi friends, so myself Reshma welcomes you again to session on database management system, and in this session I'm going to discuss with you the representation of relational algebra queries in the form of a tree. And we know the meaning of a tree. A tree contains nodes like a root, intermediate nodes, and the leaves. And here we will represent relational algebra expression in the form of a tree. For that we need to use following convention. So now here, as we know, a query tree is also a tree like data structures tree, but it is used to represent relational algebra expressions. So here the tree represents the input relations should be represented as leaf nodes, and operations will be used as internal nodes. Okay, leaf node is the input relation, internal nodes are the operations, and result will be the root. And an execution of query trees, it consists of executing an internal node operations whenever its operands are available. So if I have a child node for some intermediate node, they should be evaluated and replace that by the resultant node. And the execution terminates when the root node is executed. So the final result will be available at root node. So here we will consider three important nodes: root node, intermediate node, leaf node. Root node is the result, final execution. Intermediate node, execution of the expressions. Leaf node is the relation name. So now for example, here I have a relational algebra expressions to find the projects which are located in Stafford. I want to list the project number and the department which controls that project, the manager of the department, and specify last name, address, and birth date of the manager who is controlling the project handled by this department located at Stafford. So now the query can be written like this. Okay, so selecting project number, department number, last name, address, and birth date of the manager handling the projects located in Stafford. So now here, if you see the relational algebra expression, the relations involved, participating relations are project, department, and employee. So these three represents the leaf nodes. Internal nodes are represented using the expressions selection with condition P location equal to Stafford, then joining with the help of D number equal to D number, another join using MGR SSN equal to SSN. So these are the three operations. They should be specified in the intermediate node, and final result of selection will be done at the root node. So we can see here three relations: employee, department, and project as the tree leaf node. Selection and these two join operations as internal nodes. After final execution, the select or the project operation is the root. So this is the way to represent relational algebra expression using notations of a tree. Then along with this, we'll learn here additional relational algebra operations. Till now we have studied unary operations like project select and rename. Then binary operations we have learned separately, set operations, and then derived operation like join, division, and cross product. Other than those, we learn some additional relational algebra operations, that is generalized projection. We have learned projection, we'll see generalized projection. So now we know with the help of projection we can retrieve specific columns, specific attributes from the relation. So, but now if I don't want to select, the exact columns which are available in the relation, but I want to modify those tuples. I want to apply some mathematical expressions on those tuples and I want to represent. For example, instead of displaying the salary from the employee table, salary column is already available in the employee table, but I want to retrieve the salary column, but not exactly as that salary, but I want to increment the salary by 10% and then I want to display. So giving the increment and then extracting the salary column. So like this we can generalize, we can add some additional expressions to the existing columns and we can retrieve that come under generalized projection. And we can write this as like projection symbol phi f1 to fn. So these are different functionalities from R. So these are f1 to f1 are functions which can be applied on different attributes of the relation R. Then, as I said, for retrieving salary, incremented salary or decremented service. Okay. So for that we have to use generalized projection. So this, when these generalized projections will be used, it will be helpful while generating the reports. I want to count total number of employees available. So count of ESSN will be generalized projection. So now here one example I have report required to show I want to display net salary. So salary table will be, salary column will be replaced by salary minus deduction. I want to get the bonus, but bonus column is not available. There I may be having only year of service. Multiply year of service by 2000, then that is the bonus. To add the tax column is not available in the employee table. Salary table is column is available. Apply mathematical operation on salary. Again, that is generalized column tax. So like this, the existing column can be modified with the help of mathematical operations, and we can get the new columns according to the client requirement during the generation of the report. So it can be done like this. From employee, instead of selecting directly salary, so what we have done, 0.25 into salary, 2000 times year of service, salary minus deduction. So like this, we have generalized, modified the columns using mathematical expressions, and that will be resulted. So these are the additional type of relational algebra operations which are useful during the creation of